Hello, everybody. So today we'll continue with the last part of exercises concerning limit at infinity. So these are the examples we are going to cover. There are going to be a lot of them, but many of them will be very quick. Okay, great. Let's get started. So the first example we're going to cover, whoops, is looking at the limit as x goes to 0 plus of e to the 1 over x. Of course, now that's the limit of a composition of function, and the exponential function is continuous wherever it's defined. Now, so this basically says that I have to look, this implies that I have to look at where where 1 over x goes to as x goes to 0 plus, right? Now, 1 over x as x goes to 0 plus is just plus infinity, right? I mean, you can say 1 over 0 plus is plus infinity. And e of plus infinity is also plus infinity. Of course, this is, maybe you should not be writing this, but I mean, if you write it, that's not a big deal. Okay, so this is how to think, right? Because e of infinity is infinity. Okay, great. Let us move to the next one. Limit as x goes to, well, limit as x goes to plus infinity of cos 1 over x. Well, what is that? This is just cos of 0, which is 1, because, the cosine function is continuous wherever it's defined, and the limit as x goes to infinity of 1 over x is 0. Great. Another easy one. The limit as x goes to infinity of tan inverse of e to the x. What is that equal to? Well, e to the x goes to infinity, and arctan of infinity is pi over 2. Of course, this is a bit informal here, but this is what this says. And we have one more. The limit as x goes to infinity of tan inverse of e to the x. What is that? Well, as x goes to minus infinity, e to the x goes to 0, right? I mean, we say that e to the minus infinity is equal to 0, of course, informally. And then arctan of 0, or tan inverse of 0, is also equal to 0. Okay. Now we move on to more serious ones. The limit as x goes to infinity of e to the minus 3x sine 2x. Now here the first thing is to try to attempt the limit laws. Now the limit as x goes to infinity of e to the minus 3 to 3x is 0. This is clear, right? Because 3x will go to plus infinity, and e of minus plus infinity, which is e to the minus infinity, is equal to 0. However, limit as x goes to infinity of sine 2x does not exist. So really, I cannot apply the limit laws. But here, it's the squeeze theorem to the rescue. So, what do we know? Because, what can we say about sine 2x? Sine of something is always between 1 and minus 1. Now, since, this holds for any x in R, by the way, for any x. Now, since e to the minus 3x is positive, I can multiply these chain of inequalities by e to the minus 3x without reversing the order. of the inequalities themselves. Now, what can we say? Well, the limit of this side, well, this is here since it's not a sign here. This is really to justify the reason why the inequalities were not changed. The order of the inequalities were not changed. Anyways, let's look at the limit of the right hand side term. This is 0. And looking at the limit of the left hand side term, which is really minus the right hand side term in that case, is also 0. So if the right hand side and the left hand side go to 0, then the middle will also go to 0 by the squeeze theorem. I mean, these two are equal. The limits of the left hand side and the right hand side are equal. Then by the squeeze theorem, the limit of the element in the center, which is the limit I'm after, also goes to 0. Well, let's do one more example. So x goes to minus infinity of cos squared x of x squared plus 1 over x squared plus 1. Of course, using the limit laws, let's try to use the limit laws. I mean, using the limit laws, maybe we cannot do that because the limit as x goes to minus infinity of cos squared x does not exist. So I'm not able to use the limit laws. Now let's pay attention to something, that cos squared x is always between 1 and 0. Why is that? Because first of all, cos squared is a number that is non-negative. It's the square of a number, so it's always non-negative. And we know that cos is less than 1. And we know that cosine is between 1 and minus 1. So cos squared is between 0 and 1. Now x squared plus 1 is also positive for any x. So I can divide by x squared plus 1 without reversing the order, without changing the order, since is always positive. Now let us look at the limit of the right hand side. 1 over x squared plus 1 is 0. And let's look at the limit of the left hand side, which is also, well, it's x goes to minus infinity, sorry, is also 0. Well, the right hand side goes to 0 and the left hand side goes to 0. In fact, the left hand side is identically 0. So the center, the middle, will also go to 0 by squeeze. Okay, now we move on to we have 2 more examples left, I think. The limit as x goes to infinity of ln x cubed plus 1 minus ln x cubed minus 1. Of course, here the first thing is to try to plug in. If I try to plug in immediately, I get ln infinity minus ln infinity, which is infinity minus infinity, which is an indeterminate form. However, we know that from the properties of the ln, that ln a minus ln b is ln a over b. So let us make use of this. And write that this difference of 2 ln as ln of a quotient. It's the ln of a minus ln b. It's ln a over b. Great. What is that? This is, let us look at limit as x goes to infinity of the element or of the function inside the ln. I mean, it's easy to see that this is 1, right? By just simplifying x cubed, the dominating term on top, and the dominating term on the bottom. This is a cube here, and cancelling them out, and we just get 1. So this is just ln of 1, which is 0. It's a pretty easy one. I mean, a bit harder if you don't know the properties of the logarithm. Okay, now let's move on to the last one, which may require some work, but it's still not too bad. X squared plus 3x plus 1 minus square root of x squared plus x as x goes to infinity. Let's write first to plug in. I mean, we get root of infinity minus root of infinity, so we get an infinity minus infinity, which is an indeterminate form. And here it's the same trick by multiplying by the conjugate. Of course, if I multiply by the conjugate, I have to divide by the conjugate. I mean, of course, the idea here is not to know what the term conjugate mean, but is to know a trick that if I and a trick to cancel the square roots. Okay, of course, maybe should have written it smaller, but that's fine. Okay, let's do that now. The idea here is really to get rid of the square roots on top. So what do we get? We get x squared plus 3x plus 1 minus x squared plus x over the square root of x squared plus 3x plus 1 x squared plus x. Okay, very nice. And now what do I get? I get it's 2x plus 1 over the square root of x squared plus 3x plus 1 plus the square root of x squared plus x. Now once I plug in, I get this infinity over infinity. So I also gotta do something. Factor out the dominating term on the top, which is x. And look at the dominating term on the bottom. So in the first square root, the dominating term inside the first square root is x squared. 3 over x plus 1 over x squared. And inside the second square root, the dominating term is also x squared, 1 plus 1 over x, which is good. And now, what do we do? It's, well, I keep the numerator as it is. And I factor, I use the properties of the square root function to write it down this way, and then I'm good. Now let's notice something. Let's remember that the root of x squared is not necessarily x, but the absolute value of x. So let's do the substitution here. Usually you can do it in one step if you justify it, but let's keep it. Oops, plus 1 over x squared. Yeah, I've picked a lot of numbers. Should have reduced the amount of numbers involved in here, but that's fine. Okay, now I gotta get rid of the absolute value of x. Now if x goes to infinity, x is positive. So the absolute value of x is equal to x. Right? Because the absolute value of a positive number is this number itself. So let me do that. Okay, here I could go a bit faster, but it's good to write the steps. I mean, it's better to be safe than sorry. And write all the steps. Great. Now, after all this work, I can notice that I can factor out an x on the bottom right? Notice that if you factor out an x, that's what you get. And finally, you can cancel this x out on the top and on the bottom. And then what do you get? You get 2 over root 1 plus root 1. Is that true? Yeah. So you get 2 over 2, which is 1. And that limit is 1. Okay. Maybe it's a good example to try on your own as well. Make sure that you get it. And maybe you can try, the limit of the same function, but as x goes to minus infinity, and see what the changes are. So thank you, everybody, and I hope it was helpful.